Good afternoon, everyone. Thank you for coming. I'm Judith Flainer. I'm the Executive Director of the Trust Over IP Foundation. The Trust Over IP Foundation is a Linux foundation that is 400 members, actually almost up to 500 members now, of individual contributors and corporations that are working together to meet our mission, which is to create a complete architecture for digital trust at scale. It's an easy task, right? No, it takes collaboration, and that's why our systems work. So today we're here to talk about one of the things we're working on in one of our working groups, which is a part of our stack, and it's called the Trust Spanning Protocol. So what I would like to do is I put a polling question in your apps for you, if you can start the polling question for us. And the question is, have you heard of the concept of a trust spanning protocol? And you can be answering that while I introduce the rest of my panel here today. Today, I've been joined by 3 of our steering committee members, plus a long-term member of Trust Over IP who has used our governance meta model and is actively working with the technologies, developing things in our world, in our working groups. And so they're actually deploying this stuff. So it's not just theory. So we'll start with Andrei Kudra. Andrei Kudra is the CIO of Astatus. Although you're going to have to correct me. I always say that wrong. Say it with the German.
It's Esatus. So only one T in
I always put a T in it, Astatus.
It happens to many,
to everybody. Well, he is, and information security has been his passion since the turn of the millennium, but he's been specifically working on decentralized identity as a visionary since 2015?
That's about right.
Around there? Yeah. Okay. And then we have Christoph, who is the head of IT development and operations for the Global Legal Entity Identifier Foundation. I'm going to use what I usually call it, which is GLIFE, so you may have heard of GLIFE. And in 2017, he joined the International Organizations for Standards as the co-leader of the Technical Committee 68 and the FinTech Technical Advisory Group. So for those of you that like the acronyms, that would be ISO TC 68, FinTech TAG. And his work, he has experience in developing and implementing solutions in the financial technical industry. And then we have Daniel. Daniel Balsheimer is from Accenture. He's the Digital Identity Innovations and Technology lead there. Biometric-based digital identity has been his focus for the past 2 decades. So we have a biometrics expert in the room. With the addition of decentralized identity solutions tied to or not tied to biometrics in 2017. And last but certainly not least, we have Drummond Reed, who's the Director of Trust Services at Avast. No, sorry, Gen Digital. So for those of you that do not know the history of that, it's the ever-changing company name. He was with Evernym back when he was working on W3C Decentralized Identifier, did Spec 1.0. And you were still with Evernym when you were the author of the Manning publication, which is the Self-Sovereign Identity book that is really the definitive book on self-sovereign identity. But then it became, they were acquired by Avast, and then Avast-Norton merger, and now they are Gen Digital. So we want to put up the polling question and see what the results were here. So 92% of you have not heard of this, so this is good. This is why we are here today. So I'm going to start, you can close that now. I'm going to start with our first question to Drummond. And within the session brief, with Andre, sorry.
Yeah, I think I am.
Andre?
Yeah.
Within the session brief, we talked about the ToIP stack. Can you kind of articulate for us, give us that elevator pitch on why it is both a technical stack and a governance stack, what we call the 2 halves or a dual stack, and why are both needed for infrastructure to become internet scale interoperability?
Yeah, let me revert this with a question at first. So, what do you think is? What do you?
This would not be our deck.
The other one was better. We can do PowerPoint karaoke. That's good. Yeah. So, who of you? Well, who thinks the technical side is is easier to implement? Okay, only one hand up. Okay. So who thinks the governance side is the tough part? Okay, we're getting there. So you now already see why it's two different halves to the same equation, basically. So we need the technology. I think we have tons of technology evangelists here at the conference and all the other interesting community activities around the world. So this is not a technology topic as such. It's a governance topic and it's a regulatory topic. That's the reason why we have defined the Trust OIP dual stack in that way, that we have the technology stack on the left-hand side and the governance stack on the right-hand side. And we have currently defined the 4 layers of it. And you see, this is a cool slide representation. Let me get up. It is a very interactive model on the Trust OIP website, which is even cooler to look at and slice and dice. But we have the layer 1 where you have the trust utilities, the basic layer of verifiable data registries and this good stuff. And this is kind of the baseline where we start off. And then we get on the agent layer where we have peer-to-peer communication. And this is always both on the technical side and on the governance side. We implement technology, but we have governance frameworks driving the implementation and the use of the technology. So we have layer 2, peer-to-peer communication protocols, so agent-to-agent communication, really vital in a really decentralized world. And layer 3 is the trust task protocol. This is usually something like credential exchanges. So you get data in this commonly known issuer, holder, verifier model across the stream. And this is what happens on layer 3. So credential exchange is one great example of this trust task protocol. And then we are not at the application layer, but coming to that, because all this is needed to build the applications, which is what the end users do with all that. So this underneath is what we as an industry have to solve, but the application part, this is the upper layer to make this all easy to use, convenient, and secure at the same time. This is our task, so that the user experience is really cool on the top layer. So I think probably Drummond would have told it totally differently, but I think having all this underneath is what is vital that we get to the great experience on top. And this is why we do it on both ends, technology and the governance side.
Thank you, Andre. And now, to the meat of the topic today, which is the Trust Spanning Protocol and why we need that, I'm going to invite Drummond to focus on that keystone protocol that we are working on right now, or set of protocols, and why it's so important to interoperability at scale.
And Andre explained why we have the 2 sides of the stack. And we are known at Trust OIP, as he explained, for the governance side, the Trust OIP meta model, the governance tools we've created there. Ironically, today's session, we're going to talk about the technology side of the stack, because there are real interoperability challenges on that side too. And after spending, say, our first 18 months really focused on primarily governance, then we've spent the last 18 months focused on the technology stack side. And in doing so, we published something that's on our website called Design Principles for the Trust over IP Stack. And one of the most important of those is called the hourglass principle. And anyone who's familiar with the architecture for the internet is familiar with this general design that you can see on the left side of this diagram. That's a classic. It's actually from a I think it's 89 paper. That shows the hourglass model, and the fundamental idea is that if you want broad, scalable interoperability of a protocol stack, you need to design what's called a spanning layer. And a spanning layer has exactly one protocol in it. It's as simple as you can possibly get. All the protocols below it are called supporting protocols. All the protocols above it are the supported protocols. With the internet, as you see, we start with the wire level protocols and then up into the networking protocols, local area networking protocols. But what made the internet possible was the additional of IP, which is really just defines two things: internet addresses, right, an addressing scheme that's globally scalable, and the basic structure of datagrams for moving around data in a standard format. All the protocols above that were necessary, and I'm going to point out, actually I brought my pointer here. Oops, I got to turn it on. These two in particular, this stack is generally known as TCP/IP because you had to have that protocol to actually define essentially a messaging protocol to move around IP packets. Almost no developer uses the IP protocol directly. You either call these higher level protocols called TCP/IP, TCP, and that was actually the dominant protocol used until there were enough uses where you didn't want to establish a session. You wanted to be sessionless, and that's when the UDP protocol came into use. Ironically, I've been educated. I wasn't around at that time, and I'm not that level protocol architect. UDP has steadily gained, and every time you're watching, your favorite series. How many Ted Lasso fans out there? That's what you're actually watching, streaming over out there. So anyway, a handful of protocols there, and then many more protocols as you move up towards the application layer. So that's the basic idea of the hourglass model. One of our 18 core design principles was to say we need to do the same thing if we want trusted interoperability at global scale. And I think with everything you've heard here about digital wallets, and you think, how are we actually going to get all those digital wallets to talk to each other in an interoperable way, exchange verifiable credentials, but a lot of other things we're going to tell you about, we need a similar architecture. So we said, if you apply that model to trust, you're going to end up with these same basic 4 layers of the supporting protocols. We call that the trust supporting layer, technically. You're going to have the spanning layer that we're going to tell you more about next. And that's going to support a whole set of trust tasks that are needed by the applications. And essentially, this hourglass is going to be up here on top of this hourglass when you're using it over the internet. But we will, for any of your protocol experts, say, we call it trust over IP, but it's actually trust over any transport protocol, Bluetooth low energy or 5G or whatever. Okay. So that's why we designed it. Now, I can't remember. I think I've got one more.
Yeah,
Keep going.
Yeah, this is the slide you're really supposed to be talking about now. The next one.
The next one. Okay. So what's the design and what's the role of that trust spanning protocol? For that, we're going to go to this next slide, which shows you a much more detailed view of where we are in the design of the trust spanning protocol. And we're going to stay on this slide for the whole rest of it. So if you want to take a picture now or anytime in the rest of the session, this is it. There is a fair amount to explain here. So again, the trust support that's needed here is anything you need on a device, whether it's an end user mobile device, a tablet, a laptop, a car, an IoT device that wants to speak this stack just the way it's speaking the TCP/IP stack to be on the internet today. And that means, yes, you need a cryptographic processor, you need secure storage, you need basic transport protocols. But what we're trying to do with the trust spanning protocol is put a single thin layer over that establishes a standard way to establish verifiable authenticity of the 2 endpoints that are talking to each other. And notice mutual. We want both endpoints to be able to verify themselves to the other. Now, to do that, this whole stack relies on cryptographically verifiable identifiers. That's the best known form of that nowadays is DIDs. And I spent 7 years of my life working on the DID specification. Turns out that's not the only way to do a cryptographically verifiable identifier. Every HTTPS URL that you're using out there is cryptographically verifiable. It doesn't have some of the other properties of DIDs. They're not decentralized, but they will work. That's a way to do it. But every time you connect with an HTTPS website out there today, 99.9% of the time, it's a one-way verifiability. You are verifying that site. It's not verifying you. It's not that to say that protocols didn't support it. They do support it. It's just never been practical for you as an individual to be verified to the other end. We're saying, oh, this trust spanning layer, what's at those two ends are wallets. All the wallets you're hearing about here. Your personal wallet, but you keep hearing about the cloud wallet, or the organizational wallet you're connecting to, or the IoT wallet you're connecting to for a device. That's what's speaking that protocol. And all it needs to do is verifiable authenticity, that basically every message is signed by my private key on my side, your private key on your side, and we're verifying, okay, we don't know anything about you as a person or as an organization at this layer, but we know we've got a mutually verified connection. So
Drummond, if we had a trust spanning protocol, then what would be the next layers that we would need to have?
Boy, we sort of scripted this, didn't we? Okay, so we're going to talk about the rest of what is up here in this, what we call the trust task layer, this layer 3, right? And I'm only going to really speak to these, and then we'll go on to the other things. So there are two fundamental types, just as we talked about IP, very simple, you almost never use that protocol directly. You use TCP or you use UDP. Well, when it comes to trust and exchanging messages between two parties that want to have a trusted relationship, turns out there are two fundamental ways you can think about doing that. And one of them is, call it messaging-based. Think, what did we do with SMTP? What was the original killer app for the internet? It was email, right? We all have a standard way to move around messages between us. This is what we call trusted messaging. The closest thing out there to that protocol today is DIDComm. DIDComm has been a working group at the Decentralized Identity Foundation. Claire's here, their executive director. We work very closely with that because DIDComm is designed to be DID-to-DID communications. The only thing about DIDComm v1 or v2 is it didn't anticipate a common trust spanning layer. But we don't have Sam Kern here, do we, right now? I don't think so. He told me he had a conflict with this session. The co-chair of the DIDComm working group at W3C is working closely with us on how DIDComm will evolve to use this trust spanning layer, okay? So that's how we anticipate to handle trusted messaging. There's a second way to look at what you need to do, and guess what? That's the other predominant protocol or the other predominant architecture for sharing information on the web, on the net today, and that's the web. That's HTTP, that's state transfer. Well, it turns out there's another group at DIF that started down that path and said, we're going to do DID-to-DID messaging, but we're going to do it to exchange data and synchronize data every place you need to do it in a trusted and encrypted manner. That protocol is called Decentralized Web Node. I didn't have room to spell it out here, DWN. So there are two DIF working groups working on essentially the prototypes, the forerunners for what's needed at this next layer right above. With those two protocols, just like with the TCP/IP stack, we can start to do trust tasks that suddenly look a lot more like what we need in the real world. I mean, how many of those verbs up there would you recognize and say, oh, that's something I need to do on a regular basis on the internet in a standard interoperable way? Every one of these above, and my other panelists are going to talk about them, are protocols that now can be designed once and reused between any two applications anywhere. I'm done.
Thank you, Drummond. Never give Drummond a mic. He'll be here for 45 minutes. But that's just because he knows so much and he's been the chair of our technical working group, et cetera. But now I want to kind of switch the focus to someone who's actually been deploying this, using our stack. They first started using our governance meta model to write the governance for what they're doing. And this is Christoph. Can you explain what Drummond just talked about, all these trust stacks that are at the top? How do the trust tasks involve the use of trust registries? And can you explain what a trust registry protocol, another working group at Trust over IP that's working on right now, so we don't have siloed trust list here and trust registry there, et cetera. How would you like to explain how you're using that and how did that fit into this stack?
Sure. So the Trust Registry Protocol provides a standard mechanism for communication and exchanging between trust registries, basically. So each peer trust registry can answer to queries whether a particular party, can be an issuer, can be a verifier, is trusted for once, and is authorized, secondly, to perform particular tasks, for example, issue a credential or request a presentation. The Trust Registry Protocol also enables trust registries to disclose which peer trust registries trust each other. And that enables a governing authority of an ecosystem governance framework, such as GLIFE, to specify which governed parties are authorized to perform specific tasks in the context of this ecosystem governance framework. So as an example, in the vLEI ecosystem governance framework, GLIFE qualifies vLEI issuers to issue certain vLEI credentials. And the trust registry service would then list these qualified vLEI issuers.
Thank you. Another box up there says biometrics. And since we have our biometrics expert here in the room, Daniel, can you tell how biometrics fits into a trust task in the stack?
Sure. And 2 sessions ago in this room, Eric started talking about that a bit with the EU Digital Identity Wallet as an example. So the EU legislated and put in the ARF that authentication to the wallet, which is binding to the user to the wallet, shall be at LOA high. LOA high is defined in different legislation, is using 2 of 3 factors. One of the factors being biometric, according to yet another piece of legislation, says biometric binding would basically be the comparison of a physical attribute against an authoritative source. And Eric introduced the caution, I think he said, the buyer beware on that, because what does that mean, an authoritative source? We probably heard a lot about FIDO authentication, which is a good protocol, but FIDO protocol says that the biometric never leaves your device, right? Oops, my light is on here. Anyhow, and so, which is fine for certain applications, but at LOA high, is that an authoritative source? If I take a selfie and put it on my phone, that's not issued by the government, that was self-issued. Is that an authoritative source? I question the U.S. Department of State with our passports in the UK, Canada, US, and other countries. The government doesn't take those photos. We take them ourselves. So is a U.S. passport an authoritative source? So in a lot of these sessions, you could onboard from home, and in your identity wallet, you could scan your driver's license or your passport and put that in a wallet to bind the biometric. Is that going to be good enough for all these applications that we're talking about? I don't know.
Questions to be answered. So this just gives you a flavor, and with the short amount of time we have, we can't go over every box. So I'd like to kind of go up to layer 4, which is where the applications, the end users, and we talk about how end users is what's going to really drive adoption, right? What is a real use case for all of this stuff? So I'm going to go back to Christoph and GLIFE. Can you share with us how GLIFE has used the ToIP meta model to create governance for vLEIs, which are the legal identifiers, right, for organizations?
Sure. So here's the practical application side of things.
Yeah, practical application side, and why you feel the trust over IP stack and the trust spanning protocol is so important to what you're actually deploying out in the world for organizations.
Sure. So the vLEI ecosystem governance framework defines the vLEI operational model and how vLEI issuers qualify for and perform their tasks in the context of the global LEI system. The VLEI ecosystem governance framework was created in full accordance to the Trust over IP Foundation's standards and recommendations, respectively to the Trust over IP ecosystem governance framework meta model. And it consists now of 24 documents, which are all published on GLIFE's website. Some of the documents are basically iterations of the same type. For example, there are 6 specifications for credentials that we have defined, but still a very comprehensive set of documentation, and the structure of this was provided by the meta model. GLIFE has built the VLEI governance on the very strong global LEI system governance, and that means we have put GLIFE as the root of trust of the ecosystem and of the infrastructure of the VLEI, and GLIFE is also the governing body of the VLEI ecosystem governance framework. The ecosystem governance framework does not only guide the governance, technical, and organizational requirements for the VLEI, but actually many of them are enforced by the VLEI software that GLIFE has developed. So as a counterpart to the ecosystem governance framework, there's also a technical enforcement of these aspects. And then the Trust over IP stack was very helpful to focus on the aspects that we needed for the VLEI ecosystem governance framework. So the GLIFE framework consists of an ecosystem governance framework and a credential governance framework. So that would be layers 3 and 4 of the Trust over IP stack. And we are using the foundational lower layers like layer 2, which would be this Trust Spanning Protocol that Drummond has explained.
Thank you. And you're giving a session on tomorrow, correct?
It's on Friday, just before the lunch. So if you are very patient, then please be welcome to learn more about the verifiable LEI and GLIFE.
Great. And so as somebody who's working very closely with the EU Digital Wallet reference architecture, or ARF, right? Can you explain, in that they have designated OpenID for verifiable credentials, how do you see that exchange protocol and the trust over IP stack emergence? How do you see that kind of coming together in the future?
Well, this is a very, very complicated question, actually, because the whole
In
stuff,
2 minutes or less, no.
everything around the IDAS 2, EU Digital Identity Wallet, large-scale pilots, EPSI, and ARF is a complex mess, actually. So what you see there is, with good intentions, the regulator tries to revamp the IDAS 1.0 to a revised version 2.0, which is much more flexible, encompasses not only digital identity, government state issued digital identity, but also all the different stuff of verifiable credentials, and they call it electronic attestation of attributes. So these guys, who were very well-intentioned, tried to write up also technical specifications for this implementation, which have been distilled into the architecture and reference framework. However, not all of them really are so technical as you can expect that people who write usually laws can write technical specifications, right? So I think there is a conflict of, well, competencies or skills and expertise. This is not a bad thing, but if you want to write something that is technical, you should also involve with the experts community. So this is the place where all these trust organizations come into place, including Trust over IP, because they could have done well if they had just looked at the 4-layer Trust over IP model and did a similar job as GLIFE did and applied this construct to creating the technical specification and the law. So this all has not happened, but I think this could be a really cool convergence potential going forward to basically drive the regulation in a very expertise distilled community fashion as the Trust over IP dual stack. So if we find a way to bring that together, I think we would have even a bigger winner, because otherwise we are doing siloed things, somehow interacting because individuals interact, but not with a strong imposing a standardized unified format. So I don't know if that all totally makes sense to you guys, but I've been thinking about that quite a lot. And I think if we want to achieve convergence, we need this kind of standardized models to apply to this field to come to good solutions. And I think this is the part that TrustORP can play in this game.
Thank you. And from what little birdies tell me, there are people that are working in the large-scale pilots that are working to educate people on how, maybe we should adjust some of this stuff. So you said that the legislators shouldn't write technical standards, and I think probably most of us would agree with that. We need to influence the legislation, but not write the standards. So I'm going to give a question to...
May I just quickly comment on that just 1 second? So I think if we want to have interoperability, it would be well advised that the regulator does make some kind of technical cornerstones into the law. Otherwise, the interoperability will just not happen. This is my greatest fear, that we will have an IDAS 2, which is so great, and it will just not be adopted because it's not working interoperably. So with the implementing acts, we could have a chance to do technical specs driven down to all the member states, but this has not been done before. Laws are not to mandate everything technically. So this is going to be a very interesting field. Sorry I had to add that.
I think we'd agree with it. Ed, I'm going to ask, okay, Drummond.
It's just going to be very short, but I want to point out, because I just got messaged about it, that one of the large-scale pilots, in which my associate Andy Tobin here is quite active, has done a mapping of EIDAS2 to the TrustORP stack. He tried to get the slide to me to go in the deck, but it was already locked at that point. So if you want to see that mapping, talk to Andy after the session.
My bad, I should have known.
Andy, raise your hand. So back in the corner is Andy. Who has it? 10 years of time. So Daniel, you're on a lot of standards bodies, or in a lot of standards groups. So I wanted to talk about the standards organizations and the development communities. How does Trust over IP fit in with some of the ones we hear a lot about here? There was a whole opening session on Open Wallet Foundation. We've heard a lot about the different protocols going on at ISO and ETSI, et cetera. How does this fit in with those other standard organizations?
Right. So there was a preview from Andre and Paul and Andrew session earlier, where where we talked about DIDCOM being a W3C standard. The ISO standard associated with issuance was brought up there, or an issuance standard, the ISO 23220-3 is the issuance standard. But then there's OpenID for verifiable credential issuance is another one. So there's lots of standards. But as Andre was saying, I won't say a mess, but there's a lot of variables there. So in the initial, there was 6 versions of the ARF that came out before the final one came out, and picked 2 disparate standards for Type 1 and Type 2 credentials. So they picked a couple standards, but they're emerging. So the ISO, so we heard a bit about mobile driver's license and those standards. Well, that's coming out of, you wanted ISO SOUP, SC17 Working Group 10, the working group that's coming up with mobile driver's license standards. Working Group 3 is the passport, which is probably the largest the biggest example of a cryptographically verifiable credential, right? But it was 193 member states that picked the format, protocol, and signature that's used for that back in '95. And so for trust over IP to contribute to that, what we're working on is some of the mappings of the different protocols, the pros and cons. And I don't know if there's going to be a single protocol. It'll probably be driven by use case.
Thank you. And so, but I would be accurate to say, part of what we're trying to achieve with the stack is not a protocol to end all protocols for everything all the way up and down the stack, right? But to have just the trust spanning protocol be the minimal part that you would need so that people can use other protocols going up the stack or down the stack and making their own choices. So I would like to give a little shout out that if you did not go to the session, what was your session called? We have two of the people who were in the session today.
The one about the verifiable credential comparison and
Yeah,
the
with
protocol
you and Andrew
comparison.
Hughes and
Andrew Hughes, Paul
and
Bastian, who was
Torsten.
here, Torsten Lodderstedt, and myself did this. Well, it's a community thing that we have been doing over 1.5 years actually now.
Yeah.
So we basically compared different credential formats, and now a group has started to work to compare the different protocols for issuing and verifying, or exchange protocols for credentials. So that's something that will go on actually, and this will drive the decision making going forward. What is going to your use cases and to also the regulation. So I think this is a cool.
What was the name of the presentation that you did today? Because I'm going to tell these people
lengthy,
to go listen
So
to this presentation. I sat in it and I thought it was one of the best explaining what's needed for a wallet. We keep talking about issue, verifier, and holder. Well, there's a whole bunch of things that have to happen before it even gets to the issuer, based on the the specifications and the ARF, et cetera. And I thought you guys did an excellent job. So that's one worth listening to.
Yeah, verifiable digital credentials, comparison of characteristics, capabilities, and the standardization of verifiable digital credentials.
Now, with that long name, you see why I didn't know what the name of it was.
Yeah,
But
because we had 4 parts in it. That's kind of.
It's 4 parts. It was really great. And some of the continuing work on that is being done now at the Trust Over IP Foundation. We spun up a group to continue it, and part of it's continuing it. OWF, et cetera. So we work together as standards organizations. So with that, I want to leave the last question to you before we go to the question of the floor. What is the kind of call to action that you would have for these people and the ones listening online? Thank you for whatever time of day you are and whatever time zone you are for joining us today.
So as beautiful as this picture looks, it's not done, right? We have been working our way up. As I said, they're a wonderful set. If you're interested in governance, you can come use the governance tools, the meta model, as Christoph's talked about. It's already in implementation. In fact, fairly recently, like about a month ago, the first country that's embracing the Trust over IP stack as a whole started to give talks about it. That's the country of Bhutan. I think it's significant that the country best known for gross national happiness is embracing SSI decentralized identity as a core tool for its citizens to achieve gross national happiness. That's your big takeaway here today, okay? Anyway, as we work our way up, we are, as you've heard here, we have one task force working on the trust spanning protocol, one task force working on the trust registry protocol up here. Just in the last 2 weeks, we've identified that these protocols immediately above this, just like if this was IP, this might be TCP and UDP, are so critical to what we're doing that we want to begin working directly with those 2 groups at the Decentralized Identity Foundation to adapt the work they've done to the trust spanning protocol, and suddenly this stack starts to look really strong. What'll happen, besides the trust registry protocol, is all these boxes will start getting filled in. Where does OpenID for VC, that you've heard so much about, that we've heard has been already selected by the Architectural Reference Framework for EI-2? It's a credential exchange protocol. The whole reason for all these elaborate comparisons is there's a whole bunch of those out there. Well, about, 45 years ago, there were a whole bunch of ways to move data around. And then we had this thing called the internet. What do you want to bet that we're going to get to some standard credential exchange protocols. We're going to start to harmonize or adapt those protocols up there so that they take advantage of this machinery. Now, notice there's a whole layer here that when you only are talking about credential exchange, you're not hearing about. But at the Open Wallet Foundation, we made it clear from the very start, we're not just building wallets for identity credentials, we're building them for payment. We're building them for access, utility, car keys, hotel keys, NFTs, digital assets, all the things. And that's before we even get up here to interesting things like, well, electronic voting or digitally signing documents or delegating to your, to your spouse or your kids. All of those are trust hash protocols that get an order of magnitude easier if you have these lower layers to build on, exactly the way it did with the internet. So, call to action, come, help us finish this work, and then start to look at how you're going to adapt or use this work. And of course, that would, it would help if you join either Trust ORP Foundation as an organization or an individual, or any of our sister organizations like DIF, OpenID Foundation, Open Wallet Foundation, all of us that are working together on this.
Thank you. And with that, can you open the final poll? So we have another poll for you, which is, now that you've heard this, 92% of you had never heard of a trust spanning protocol before you walked in the door. Do you think that having this type of layered trust spanning protocol architecture would be beneficial? Yes or no? And with that, while they're doing that, did we have any questions come in?
No questions so far.
We have one in the audience, or two in the audience,
Two
if
in
you
the
can do that while
audience.
people are
I'm
doing
on
the
my way.
poll.
Thank you. This is for Andre. You mentioned complexity and you hope that interoperability is achieved. Could you talk a little bit more about the scope of interoperability? I assumed EU nation states, but is there anything beyond that? And what could be done to make sure that interoperability does happen?
Yeah, I think we have to have at least a common kind of standard set of protocols that we all want to support. But the devil is always in the details, as we say in Germany. So actually, what is quite very important in that space is that we have a test bed or test harness to which we can test against that all the stuff really works together. Because if you look at IDAS 1.0, there is something like in the IDAS bridge, which should allow you to basically use your digital identity from one of the member states and the other in a digital fashion. But I have the feeling that doesn't work so well and isn't so widely used. So basically, we want to have a strong mechanism to really test out this interoperability. And all this can obviously help to select the protocols, and in the ARF there are also already two selected and credential formats selected. So this is one point. What I have as a vision, and I mentioned that earlier in another session. So I think at one point in time, we don't want to compete about these protocol things anymore. We just want to make this as commonly used as TCP/IP. So if you buy a router or any type of device today, you just want it to use the protocols that are used by the other things, so that you don't think about it, does it work together anymore? So exactly on this layer above, with this trust architecture, trust spanning, we need the same. So basically all the vendor products or custom implementations that want to do something in this trust world need to support this protocol. And you don't want to think about this anymore. So you don't make bespoke applications for identity and access management, like all the good people out there probably have done for years. So we want to make this interoperable seamlessly out of the box. That's my vision.
One more question, but I want to also note that we are done with time, so the keynotes are starting upstairs, so if you need to leave, but we will take the time for the last question. And I will say, until we get the credentials inside the phone, if you need something to stick on the back of your phone to put your current credentials in, please feel free to grab some, and we have some stickers up here as well. Thank you for attending. Go ahead and ask your last question.
Hey, I'm Paul. My question, like maybe two questions. So, how much is DID and DIDCOM tied to the Trust over IP stack? And what's the technical foundation, like what's the technical protocol for the trust spanning layer 2?
So first of all, I think the first half to answer your question, so the trust spanning protocol is between cryptographically verifiable identifiers. The best known are DIDs. We're not saying that's the only thing possible, but it's going to have the characteristic of DIDs, and not all DIDs are going to actually meet the requirements, right? For instance, you're going to have to support key rotation if you want to do the trust spanning protocol, on an ongoing basis. So you asked how closely is DIDCOM tied to it? Today, DIDCOM, because there was no trust spanning layer, DIDCOM does not require it. In fact, what the DIDCOM working group is now, our very last meeting was with the DIDCOM working group to basically say how can DIDCOM, what may become DIDCOM v3, incorporate the trust spanning layer so it doesn't have to define it itself, but it's using a common layer, and actually decompose some other things that are in DIDCOM up into trust tasks. So DIDCOM gets thinner and more universal as a trusted messaging protocol because it's using that. The discussion with DWN and that working group is just beginning. They too have had to do their own way of defining authenticity and encryption. And so we've got different ways of doing that, whereas with this stack, we could have a common way of doing that. And we think that same thing is going to happen with protocols that are designed at the higher layer, which is exactly what happened with the TCP/IP set of protocols. There were all kinds of ways to do things that today are just SMTP and HTTP, and we all know the results. We believe we need to do the same thing for trust.
So a nice way to say that is each one of those protocols will get thinner in what's defined in it because it isn't needed to do it. It had to do it originally because there wasn't anything else.
Exactly.
And that's what they're working on, and we are working with people at DIF come to our working groups all the time. If you ever want to come, we have one for Europe in the morning, one for Asia in the afternoon. Some people go to both of them so that there's cross conversation. So we'd love to have you. Is that it? Well, I really want to thank you for coming. We do have the result of the thing, but I hear they have technical difficulties, and so far, based on the respondents, I don't know if they closed the poll already, 100% thought that the trust spanning protocol and having a layered architecture like this was beneficial. So, yes.